All right, good afternoon, students. So we are learning our last new lesson that goes along with Unit 7. We previously have learned how to write linear equations in all three forms: point slopes form, slope-intercept form, and standard form. Now what we're going to use is we're going to use that knowledge to help us write equations for something called best fit lines, or lines of best fit, or trend lines. You may have heard of these in maybe science class, you've done them. Usually students have heard it a little bit because you've kind of done some lines of best fit usually in elementary school where you draw them, but you don't write the equations with them. So let's take a look at what do I mean by best fit lines. And I do want to tell you guys before we start this lesson, some of you guys going into this are going to be a little frustrated. This is a lesson where there are many correct answers. And it's all based on how you draw your line of best fit and what your equation will be. So as I'm doing my examples, as long as your slopes are really similar to what I have, when we write our final equation, as long as your numbers are close to each other. Like for example, if I get a number of 50, something close to that, like 25 to 75 is probably fine. But if I have a number of 50 in my equation and you have negative 35, probably did some math incorrectly, okay? So I do want to let you guys know before we get started that most of the time you guys are used to having one correct answer in math class. There can be lots of correct answers because each and every single one of you guys can write a different line of best fit, okay? So I'm just going to let you guys know ahead of time as we look at some more examples. That'll make a little bit more sense, okay? So before we actually look at drawing our line of best fit, which is our ultimate goal for this lesson, we have a couple vocab words that we need to take a look at. The first one being a scatter plot. So a scatter plot shows the relationship between a set of data with two variables. They're graphed as ordered pairs on a coordinate plane. You'll notice down here, these are examples of scatter plots. They're dots that are kind of all over the graph. They don't make a perfectly straight line. They're just dots. So for example, I might do a scatter plot to compare your age to your height. Because typically as you get older, your height increases. I might do some kind of scatter plot that compares your number of hours watching TV to your test scores. It's not going to be the exact same number on for each dot because some of you guys can watch a ton of TV and do really well on tests. Some of you guys watch no TV and still struggle on tests. So with scatter plots, the dots can kind of be everywhere, okay? But they end up being ordered pairs and you just graph them, okay? For today, I'm going to have all the scatter plots ready for you guys. You'll get a chance to practice them next week when we do our Barbie Bungee project. Then we have something called a correlation. Hopefully when you see correlation, you see the word relation or relationship with it. And a correlation is the degree to which the two variables are associated. There are three different types of correlation. There's something called a positive correlation. It's called a positive correlation because notice these dots move upwards. Think about it this way. Slope Dude would say this is puff puff positive as we're reading these dots. In general, these dots are moving up. That's why this is a positive correlation, because in general the dots are moving upward. So an example of a positive correlation, like my previous one, as you get older, your height increases. So notice that that would be going up. As you get older, your height keeps going up. Another one, the more that you study, your test scores go up. That would be an example of a positive correlation. Another random one, the more times that I go to the doctor's office, the more expensive my bills are going to be, or the more that I've spent. That's a positive correlation. The more money I put into a savings account, the more money I have saved up. That's a positive correlation. So the numbers continue to go up. The other type of correlation we could have is a negative correlation. That's when the dots, for the most part, move in the downward direction. Slope dude would say, this is nice negative. So notice all the dots tend to move as a whole in the downward direction. Not at the same rate, but they move in that direction. So that's an example of a negative correlation because it goes downward. Examples of a negative correlation in the real world. As a car gets older, the value of it decreases. The example I gave earlier, the more TV you watch, your test scores go down. Trying to think of another example. The more money you spend, the less you have available, kind of thing. So think about one is increasing, something else is decreasing. So that gives us these points that move in the negative direction. Then this last one we have is something called a no correlation, where the dots are just all over the place. There's no kind of direction on which way they go. As I look at this one, the dots are just absolutely everywhere. It doesn't give me a clear direction. Are they moving kind of upwards or are they moving kind of downwards? They're just all over the place. So this is when you think about comparing two really random things. So for example, I might compare the price of someone's house. So as someone's house value increases, their value of their car increases. I'm like comparing the value of my house to the value of my car. There's absolutely no relationship there. Some people would rather spend a lot of money on a really nice house and have a really old car, and that's fine. Other people want a really inexpensive house so they can have a really fancy car. Some people are right in the middle. Those dots would be kind of everywhere. Let me give you a really good extreme of two things that we would just never compare. Oh, would I ever need to compare your height to your grade in math class? I mean, I could, but there'd be no relationship there because your height and your grade in math class have no relationship between them. If I were to do that, your dots would be all over, creating a no correlation. Okay? And again, we could do that if we wanted to, but you'd find the dots are absolutely everywhere because your height has no impact on your grade in math class. So just in general, I want you guys to think about positive correlation, the dots tend to trend in the upward direction. Negative correlation, the dots tend to trend in the negative direction. Think about puff, puff, positive, and nice negative. All right, when we identify that there is a correlation, we can draw what's called a line of best fit. It's also called a best fit line. It's also called a trend line. It is a straight line that best represents data on the scatter plot. The line might pass through some of the points, none of the points, or all of the points. It just depends on the numbers that we use to make our scatter plot. The important thing is that it goes in the same direction as the correlation. So for example, this one was a positive correlation. So when I drew in this line, notice that it moved in the positive direction. It is not a connect the dots type of thing. It basically, do you see kind of how this red line, it cuts all of the dots in half? So half the blue dots are above it, half the blue dots are below it. That's our ideal goal. This line can be different for each and every single one of you and still be correct. As long as it follows the same correlation, chances are it's correct. Example, or this middle one here, is a negative correlation. And so notice that our line is nice negative. And again, notice that it goes, kind of cuts through the dots that are on my scatter plot. And this last one, no correlation. If there's no correlation, we can't draw a line. There's no line that can be used to describe it at all. So if you ever see a no correlation, which I will tell you there is none like that on the homework assignment, but in real life, if you see something that's a no correlation, you wouldn't be able to draw a line of best fit. Now let's talk about real life here just real quick since I said that. A lot of you guys ask the question, when will I ever use this? You might be using this in your job where you are doing a survey and you're collecting data and you want to put all of that information on a scatter plot to help you to make predictions. You might be someone who does research. I have a lot of friends who are in the science fields, and so they do a lot of research. They are comparing trees in a certain forest or something, and obviously there's a lot more to that. But they make a lot of scatter plots and use lines of best fit to help us to make predictions. Remember, math is all about kind of finding patterns to help us to make predictions later on. So our big goal today is going to be being able to draw this line of best fit and writing the line for it to help us to make those predictions. The very last thing that I want us to practice here is I want us to practice like what it means to interpret. So we want to explain the meaning of the two quantities. And we'll take a look at an example of that here in a little bit. This is one students tend to do really well on because it's kind of intuitive. It's how you would explain it to me probably anyways. So what I want to do first, before we even start drawing our lines of best fit, I just want us to look at some scatter plots and talk about a few things with it. So on this first one, this graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, negative correlation, or no correlation. If there's a positive or negative correlation, we're going to describe the meaning. So let's take a look at this graph. The years are increasing this way on the x, the number of students per computer on the y-axis. In general, are these dots, as you read from left to right, are they going upward or are they going downward? Think about the slope dude. Slope dude would say, nice negative on this one. So we're going to say that this one has a negative correlation. And I'm okay if you just write the word negative. And you could even just write out NEG. I know that's going to be negative. That is perfectly fine. So let's describe what it means. It means as the x values increase, so notice as our years increase here, what's happening to our students per computer? It is decreasing. So our interpretation of it or describing the meaning is going to be as years increase, the number of students per computer decreases. So the interpretation again, we'll talk about as the years increase. We're always going to talk about how the x values increase. What happens to the y? So as years increase, so as these years are increasing, the number of students per computer is decreasing. Now, as you guys are writing that down, I want you guys to think about, why would that happen? Think about, like, I graduated in 2005. Do you think, I'm not that old, but I'm old. Do you think we all had an iPad? Nope, I don't think iPads were out when I graduated. Oh man, that makes me feel really old. But I want you guys to take just a minute or two. I want you guys to think about and have a quick little discussion. Why would this correlation happen? As the years have increased from, say, 2000 to 2017, why would the number of students per computer have decreased? So, go ahead and press pause, have like a 2-minute conversation, just because I think it's really good for us to discuss these correlations and what the data means and why that makes sense. So go ahead and discuss for 2 minutes. All right, hopefully you guys had a chance to discuss. Hopefully you talked about that computers are just needed more often, they're less expensive, and schools have realized that they need more computers per student. Hopefully you had more of a conversation with that too. Let's take a look at another one. This one's silly. I stole it from the book. It's not a great example, but it's okay. So again, the idea is the same. Look at the graph, determine whether it's a positive, negative, no correlation, or choice D, can we not decide? On this one here, hopefully you're recognizing the dots are moving upwards. If it's moving up, we're thinking about this is a positive correlation. And the interpretation is, with each year, the number of mail order prescriptions has increased. Or, in our words that we used, as the years increase, mail order prescriptions increase as well. Okay? So think about when you're describing it, if it's a positive, both X and Y labels are increasing. We're not going to discuss this one because this is a silly one, but I just needed another example. Okay. Here's where the real practice comes in and what you guys are going to be doing on the homework. Again, not due till Tuesday. First thing you're going to do is you're going to make a scatter plot. You're going to practice that next week, Tuesday and Wednesday. But you are on the homework going to be determining whether any relationship exists in the data. We will continue to practice that. Step 2, you're going to draw a line that seems to pass close to most of the data points. Again, it's not going to go through all of them. It's going to kind of cut them in half. Then step 3, and this is the part where you'll start to see the person sitting next to you might not have the exact same answer as you guys. And I'll be honest, you guys, if I happen to see someone's homework assignment where it's identical in numbers to someone else, it's going to make me really kind of think. Because in these ones here, for the most part, the numbers are not going to be identical to each other. They're going to be close, but not exactly the same. So step 3, we're going to use 2 points on the line to write an equation, which we have been practicing, and you guys did a quiz on yesterday. Then again, the purpose of an equation is to make predictions. So our last thing that we're going to do is we're going to use our line to make some predictions. We're going to say, what if this situation happened? What's our best guess? What would be our best guess for an answer on that question? That's, again, the point of these lines of best fits. So I'm going to start us off with a multiple choice question. These are common types of lines of best fit that I would see for it. Only one of them is correct. So we want to talk about which one shows the best fit line. All of the graphs are identical to each other. The only difference is their lines. So let's look at example A. So in this one, if I look at the dots, what direction do they tend to move? Do they tend to move upwards or downwards? Hopefully you guys are seeing as I'm kind of highlighting them. They are moving upwards. Does this line have a positive correlation? Is this a positive or negative correlation? Hopefully you're saying this one's a negative. Well, if the line is negative, this one doesn't work because the line does not match the same direction of the points. All right, example B. So we just talked about it has to have a best fit line that moves upwards because our dots are moving upwards. Does this line move in the upward direction? It does. Does it kind of seem like it could cut the points in half? I mean, it looks pretty close. So this one's a maybe. Let's come back to that one. In example C, we again have talked about the lines move in upward direction, or the dots, I'm sorry. Does this line go up at all? Hopefully you're thinking, no, it goes straight across. This one does not have a best fit line that has a positive slope to it or positive correlation. Example D. This line goes up, so could this one work? Unfortunately, this one does not work either, because am I tracing over an entire straight line? Is this whole line straight? It is not. This person did more of a connect the dots thing. Lines of best fit are a perfectly straight line. And the great thing is with your iPads, you can make straight lines, and I'm going to expect you guys to be doing this by holding down when you make your line, holding it down. And so that way makes a perfectly straight line. I do want you guys to be practicing that. So process of elimination. Choice B is the best fit line of the ones we have to choose from. I personally don't know if I like this best fit line. I might have drawn something different, but this one is still technically correct. All right, so now let's actually get down and practice what you guys would be doing in the real world and writing equations. So this graph that I have shown here, it talks about the price per ounce of cereal. So let's say I have Fruit Loops. You guys may have noticed, especially if you shop at Sam's Club or Costco, that the bigger the bag or the bigger the box, if you were to calculate the unit price for it, it's usually cheaper to buy the bigger box per unit. So someone looked at a bunch of cereals, and they plotted this information compared to their price. And we ended up with our scattered plots. First thing, let's determine if there's a relationship that exists. Do these dots as a whole tend to move up or down, or are they just all over the place? Hopefully you guys are kind of thinking as you're tracing over them that notice my pen as I'm clicking on them is moving downward. That means this one has a negative correlation. So I'm just going to write it there because I know I'm going to need the rest of the space for this. Now we're going to draw in our best fit line. Here's one of my requests for you guys as you're doing your homework here. I need you guys to select a pen choice on Notability that is thin. A lot of you guys like to use the thick part of the pen choice. I want you guys to choose a thin option. Otherwise, it's going to be really hard to find some of your ordered pairs. So go ahead and real quick, select a thin one. Then we're going to draw a best fit line that cuts most of these points in half. Now I'm going to draw one in. It might be different than yours. I'm going to draw in some in blue here that would be fine. I'm going to draw some that would not be okay. All right, I'm going to go ahead and draw one in. Now, unfortunately, I can't make a straight line like you guys can. And again, hopefully you guys all know how to do that on Notability, where you just draw a straight line and hold it, and then Notability would automatically make it a perfectly straight line. So I'm going to have to do my very best with mine to try to make mine be straight. But it won't be perfect. So, yeah, it's not very straight, but hopefully you get the idea. Notice that my line moves in the downward direction, okay? I try to cut the points in half. So this would be a good example. I would be perfectly fine with something like this on your homework. I'm going to draw some in here real quick in red that I would mark wrong. One of them I would for sure mark wrong. If you drew something like this. The one that I just drew in would be incorrect because it has a positive correlation in red, the one I have in red. But we said our dots are negative. So that one wouldn't work. I would not take a negative one that looked like this because this red one doesn't even go through the points at all. It's all the way below it. So this red one would not work. This red one would not work either. Because again, it's way above the points. Does not even come close to the points that are on my scatter plot. Sometimes I see this. See where my points are. That one doesn't work because it's not a straight line. So those are things that I sometimes see with lines of best fit, but I would mark those wrong. As long as your line kind of goes in that downward direction and cuts through your points. Here's what I'd like you guys to do. In just a second here, I'm going to have the video paused. I want you guys to show your line of best fit to someone else and see if they agree with it, okay? When I'm back tomorrow, I will practice this with you guys too because I do want to make sure you're drawing these correctly. So see if your partner, someone next to you, would agree with it. If there's a discussion, see if you guys can ask someone else to help each other out with your lines of best fit. If you still have questions, I'll help you tomorrow, okay? But go ahead and press pause. Take a minute, compare your line of best fit that you drew to see if it would be correct. All right, now what we're going to do is we're going to write our equation, okay? And again, this is where some of you guys might get a little frustrated because your line is not exactly the same as mine. So technically, your equation is going to be different, okay? What I'm going to have you guys do in this first example is I'm going to have you use my numbers so we all work through it the exact same way, okay? So the directions tell us to write this equation in slope-intercept form. Hopefully, you remember slope-intercept form is y equals mx plus b. And there are multiple ways that you guys know how to do this now. I don't care which way you use. I'm going to kind of keep it consistent with what we've been doing in this unit, but some of you guys are starting to realize there are other ways to write in slope-intercept. So we drew in our best fit line. Now I need to pick 2 points that are on my graph. So I'm going to take a look and see if I can find 2 points that fall on my graph. Again, ideally I'm looking for points that intersect at some grid corners. So I'm going to see, this point right here is pretty darn close. Let's use it. It doesn't have to be exact. So I'm going to put a dot here. And I'm going to just write up here that that is the ordered pair 570. Let's find another ordered pair. Ooh, this one right here, at least on mine. I have another one that's pretty close to here. Okay, so I'm going to use 1540. And for the sake of this problem, I'm going to want you guys to use these same numbers. Just so we can work through it together. On the next problem, your answer is going to be a little bit different based on your line of best fit. Okay? Let's go through and write an equation. Well, any equation we write, we need to find the slope. So let's find the slope between these 2 points. So I'm going to take y2 minus y1 all over x2 minus x1. 40 minus 70 is negative 30. 15 minus 5 is 10. So my slope is negative 3. From here, to be consistent, when we're writing an equation in this unit, we've been starting in point-slope form, and then we'll solve for y. Again, there is another way to do this one. Totally fine as well. So I'm going to choose my first point, and I'm going to plug into point-slope form. So y minus y1 equals slope, parentheses, x minus 5. No fractions to clear. Woohoo! So let's distribute. So y plus negative 70 equals negative 3x plus 15. getting y by itself. Let's go ahead and add 70 to each side. So y equals negative 3x plus 85. Here's slope-intercept form. Now, just to give you guys an example, with this problem and how I just did it on here, this is the equation I came up with. Tomorrow, after I post the answer key to the notes, you'll find the equation on my answer key is not exactly the same as this. They're really darn close to each other, but they're not exactly the same, and that is perfectly fine. So that first step is to write the equation. Then from here, we're going to go through and make a prediction. So the next part says use your equation. So you're going to use this equation that we just found, and we're going to predict the price for 7 ounces of cereal. Basically what that means is you're putting 7 in for x in your equation. So I'm going to write my equation exactly as I see it. Instead of the x, I'm going to put in the 7. So when you're making the prediction, you're putting in that number in for x. Plus 85. Typing this into your calculator, I have to do this real quick because, like I said, my answer key has something different. So I end up with y equals 64. So what this means is I'm estimating if I went to the grocery store, if I went to Target, if I went to Cub, if I went to Hy-Vee, Byerly's, whatever, if I were to buy 7 ounces of cereal, this equation says, oopsie, this equation here says that I would be paying about 64 cents per ounce. That's what we're doing, is we're making a prediction based on our best fit line. But again, this is not going to be true every single time. It's just a good guess. You guys all know when you go to the grocery store, there's the brand name cereals. There's your Kellogg's, your General Mills, your, I don't know, Post cereal. And then you also have your store brand. And sometimes there's a brand in the middle. So this is not going to be true every single time. It's just a good guess. And that's what best fit lines are for, is to make a good guess about what could happen. If you have questions, try to talk them out. Again, I'll be back tomorrow, kind of help with stuff. All right, this is our last example that we're going to look at today, okay? This example says, the graph shows how many, oh gosh, I have a typo in here. The graph shows how long, I should take out the many. The graph shows how long it takes to read a certain number of pages. Determine if a relationship exists. If so, write it in best fit line. Draw the best fit line and write the equation. So take a look at these dots. I'm going to kind of jump all over them. If I look at these dots, do they tend to move upwards, downwards, or are they just all over the place? Hopefully you guys are identifying that they are moving upwards. So we're going to say that this has a positive slope. Now what I want you guys to do is I want you guys to try to draw in your best fit line for this one. So everyone try to do that. If you guys can pause the video for just a second, I'm going to draw in what I think is a good one. And then if you guys have some discussions from there, you can see if you can help each other out as far as why it is a good best fit line or why not so much. Okay, let's go ahead and press pause, make your best fit line, and then we'll see if we kind of agree. All right, your line of best fit should look something like this, okay? Make sure it cuts the points in half and it moves in the upward direction. If you guys have questions as far as like, oh, I'm not sure if mine is right or wrong, again, have a discussion, try to help each other out and figure out if your best fit line is good. Tomorrow I'm going to come around and look at each of your best fit lines as we do our examples to see if you're on the right track with them. Okay? Now, let's go through and I'm going to identify 2 points that are on my best fit line. So on my best fit line, I see there's a point that's pretty close to 10 and 200. It's okay if it's not exact. As long as it's close, again, that's fine. If we wanted to get exact, we'd use like a computer to do this for us. All right, then I see another point right around 20 and 350. So these are the 2 points I'm going to use when I write my equation. What I want you guys to do, I'm going to make some notes for you guys here real quick. I would like you guys to work on these things. 1, you need to find 2 points. 2, find your slope. And 3, using any method you want, write your equation. If your line is pretty close to mine, you can use the 2 points that I suggested, or you can pick any 2 points that are on your line. Here's what I want you guys to do. I want you guys to do these 3 things. I'm going to have the sub pause the video. I'm going to write down my work and my equation, and then talk to you guys about how if your answer would be close or not, okay? And then we're going to use it to make a prediction for it. So this is the part where some of you guys are going to have different answers than what I'm putting on the board and who's sitting next to you, okay? So press pause, try this to write this equation, and then press play and I'll show you what I end up with, what my equation is. All right, so the equation that I ended up with is y equals 15x plus 50. Here are things I'm going to be looking for when I grade your homework, when I grade your tests. I'm going to be looking for 1, you better have a positive slope. If your slope is negative, I'm automatically marking it wrong. Your slope should be somewhere around 15. Usually when students have done this in the past, I think maybe as small as 5, but I think I usually get between 10 and 20 for a slope. But in all honesty, I'm kind of lenient with it as long as your best fit line makes sense and all your math is correct. Then that's fine with me. Your B value, the number being added or subtracted at the end, I would say somewhere between 50 and 200 would be fine. Mine's kind of probably a little bit on the low end, but somewhere kind of in that range would be acceptable. So you could have multiple answers for this. Again, what I'm going to look for, does your best fit line make sense? Are your points correct? Did you do the math correct? If you did, your best fit line is perfectly fine. If you have questions, I can talk to you guys more about this tomorrow. And if you're not sure if your answer is correct or not, I'd be happy to take a look at it tomorrow. A good way to know if your answer is correct is when we make our prediction down here. I'm going to use my equation. You use whatever equation you found. So I'm going to use y equals 15 times, and I'm going to put 32 in for x, plus 50. So when you're using your prediction, you're using your equation and just plugging in that number. When I actually calculate that, we end up with y equals 530. So your answers are not going to be exactly 530. Again, I'm going to be looking for close. I'm trying to think about previous answers. I would say anywhere between 450 and about 650 is probably a good answer. Okay? Again, all I'm looking for is if your line makes sense, your equation is correct, then your prediction is fine with me too. Okay? Because again, you can get different answers here, and some of you guys are going to struggle with that. But please just trust me that with lines of best fit, you can have different lines and different predictions, because a prediction is not meant to be exact. So here's what we're going to be doing tomorrow. We're going to take a look at how do I write an equation in standard form. So we're going to take a look at a couple more examples so I can be here to help you with it. These are ones the students tend to have a little bit more difficulty with because most of you guys don't like standard form, even though you're getting better at it. Most students are not a huge fan of standard form. But from what I've glanced at with your quizzes, you actually did a really nice job on that. So we're going to do 2 examples like that. Oh, and then one more. I forgot you had another example. But here's what's happening. You do have a homework assignment due for Tuesday. It's the Best Fit line worksheet. It only has 4 problems on it. If you would like, you could try the first 2 if you wanted to. Friday, we are going to finish the notes. Monday will be a work day on this homework assignment. Okay? So if you wanted to wait till Monday to do this, that is perfectly fine. Otherwise, I want you guys to be working on missing assignments, redos, or preparing to retake the test if you would like to. Things coming up next week. We're going to have the unit test on Thursday. Just a reminder, Unit 6 end date is on Friday, so make sure you get all that stuff taken care of. If your anxiety is through the roof right now, totally normal on this first day, let alone me not being here. I will help tomorrow with it and on Monday as well, okay? So if you have a lot of anxiety with it, there will be time so I can help kind of make it better. Have a great rest of your day. If there's any extra time, you guys should be finding stuff quietly to work on for math then.